Hey, this is Shivam Nikam, roll number 34, and this is my topic for CCIA2. So, I have performed a survey on the research paper of performance analysis and modeling of video transcoding using heterogeneous cloud services. So, giving a brief intro, the cloud computing has become increasingly popular in the recent years and it offers many benefits such as cost savings, scalability, and flexibility. The delivery of cloud services, including server, storage, database, networking, over the internet have made the implementation of various services like modeling of video transmission very easy. Also, it is used in various businesses like healthcare, education, and entertainment. So, we are focusing on the entertainment field. Okay, the methodologies of performance of analysis and modeling. So, firstly, we'll perform the experiment design. We set up the experiment to analyze the video transcoding with different cloud services. Then we perform the data collection. We collected performance statistics and analyzed them. So basically, all the different videos, the format in which the videos are there, the data and the libraries which we need to support the basic framework are all collected. Then the performance metrics. Once the cloud service has hosted the video content, then the execution time of different video transcoding, the time taken for the operations using different cloud virtual machines, execution, etc. was measured for each operation on each VM. The results showed that different VMs have different execution times for the same operation. Also, analyzing the task machine affinity of video transcoding operations with virtual machines refers to the relationship between specific video transcription task and VM it is executed on. Fourth step is modeling. We create a probabilistic model to predict the performance outcomes of various scenarios. Collecting the data and performing the performance metric, we needed a model to create and predict the performance outcomes. So we use group of picture size and frames using two key parameters in video transcoding. Then different combinations of this group of pictures are tested on different virtual machines. The results show that both parameters have a significant impact on transcoding time. Overall overview of the performance cost trade-off on transcoding on VM shows that there is a trade-off between performance and cost when using heterogeneous VMs for video transcoding. Findings from the study. So, as we discussed, there was a trade-off between the performance and the cost. So, basically we found that some cloud services perform significantly better than others in terms of transcoding time and cost. And in factor of video size, our research indicates that transcoding time and cost are highly dependent on size of the video file. As we see, videos are a group of images and different images are grouped together to create a video. Also depending on the frames per second of a video, like the amount of frames or the amount of images that are visible within a second greatly contribute towards the video size. Also in the process evaluation, we evaluated on basis of several metrics. So the make span cost and efficiently shows that the proposed model can effectively balance the use of heterogeneous virtual machines in the cloud. Also, several studies explore that the use of cloud computing for video transcoding allows for scalability and cost efficiency. So, coming to the effects on the infrastructure, we found that infrastructure such as CPU, CPU, and other network bandwidth have significant impact on the performance. But using cloud as a service, we can use it in a scalable way. Implications of the study. First thing was the cost optimization. Our findings suggest that by choosing a cloud service with the right infrastructure, video transcoding cost can be sustainably reduced. Then, coming to the resource allocation, our research indicates that increasing CPU and GPU resources can lead to significant improvement in transcoding time. Also, as the CPU and GPU are readily available as cloud services, which prevent the initial investment of the user. So one does not need to go and buy high processing, high computing parts for their hardware. Then the finally quality control. We found that the video quality is highly dependent on the cloud infrastructure and that careful monitoring and tweaking is necessary to ensure high quality output. Recommendation or optimization of video transcoding in cloud environment. So, infrastructure planning. Planning infrastructure requirements in advance and allocate appropriate resources such as GPU instance for specific workload. Monitoring, testing and benchmarking. Conduct through test and benchmark of the cloud service to select one that meets your specific needs the best. So various infrastructure as service are available on cloud. Also we can apply different combinations of host and the kernel and the basic hypervisors which you can host our videos on. So basically we can test them by benchmarking. Monitoring and metrics. Monitoring transcoding performance and use of metrics to measure the effectiveness of optimizing strategies. So metrics such as transcoding time, cost, resource allocation are used to monitor the various parameters of video transcoding. Automated scaling. Automate scaling of cloud resources to meet the demands during peak periods. So this comes basically to the scalability part of the cloud. As we all know, cloud can provide increased services if the need is more. So an example of meeting the demand would be if a popular video has been hosted on a basic video software, which you can say the most commonly used is YouTube. So if one video has been trending, more resources are provided to the streaming of that particular video. Conclusion. In conclusion, video transcoding is a complex process that can be optimized with the route cloud services and infrastructure. Our research highlights the importance of infrastructure planning through testing and benchmarking and carefully monitoring the performance using the various metrics provided. By following these recommendations, organizations can optimize the video transcoding in the cloud and provide a better video for their users. So overall summary of the paper, performance analysis of and modeling of video transcoding using heterogeneous cloud services, provides that the performance of video on heterogeneous clouds aims to analyze the model of the performance of the video under different scenarios, including the use of different VM times, video stream structures, and video content, which we saw in the previous metrics, to basically provide a better quality of video for their users. Thank you.